Hi, in this video we are going to talk about recursion. Recursion is a way to solve a problem or a way to write a program in which a function calls itself. Before we talk about recursion in detail, how to write recursive functions, what are the applications, let us first make sure that we understand function calling really well. So as an exercise, please take a look at these programs and try to get the output. So if you're a C++ programmer, you can take a look at this program, and if you're a Java programmer, you can take a look at this program. The output of this program is before fun2, before fun1, fun1, after fun1 and after fun2. Let us see how are we getting this output. Whether it is a C++ programming language or Java programming language, execution begins from main function's first line. So our execution begins from this line. So main function is the function that is called first, and when main function is called, it starts executing from the first line. So the first thing that you see on the screen is this line's output, which is before fun2. Now main goes to the next line, and next line is a function call. Now what happens is main function is stopped, right, and it's going to resume its control back once fun2 is over, and control is given to fun2. So fun2 now begins its execution from this line, and what does this line do? It prints before fun1, right? So we get before fun1 on the screen. Then fun2 continues its execution to the next line. So fun1 is called, and now when fun1 is called, fun2 is stopped, right? So main is stopped, then fun2 is stopped, and now fun1 is called. And now fun1 begins its execution from the first line. So fun1 begins its execution from here. And what does this line do? It prints fun1 on the screen, right? Fun1 called, and it printed fun1 on the screen. And fun1 has nothing more to do. It's not making any function call, not doing anything else. It's just printing fun1. So whatever it is doing, all that is done, and once fun1 finishes its execution, once it executes its last line, the control is given back to fun2. Now fun2 gets the control back, and fun2 resumes its execution from the line just after the call of fun1. So fun2 executes this line, and after fun1 is printed on the screen. And this was the last line that fun2 has to do, right? So now fun2 is done. So control is given back to the caller of fun2, which is main. So main gets the control now, and main was waiting for fun2 to finish. So main gets the control and now executes the line which is after call of fun2 in Java here, right? So now you get after fun2 printed on the screen, and then there's nothing more to execute in the main function. Here we have written 0, here we have nothing. So this is how we get this output: before fun2, before fun1, then fun1, then after fun1, then after fun2. I hope you now understand function calling really well, how function calls work. So if there is a function which is calling other function is calling some other function, then the last called function finishes its execution first. It gives the control back to the caller. Then caller gives when the caller is finished, it gives control back to the caller of the caller, and this is how function calls execute. Now we understand how function calls work. Let us now take a look at recursion. A function is called recursive if it calls itself directly or indirectly. So here is an example of direct recursion. There is a function fun1. It calls itself somewhere in its code, right? There might be some other code here, some other code here, and it is calling itself. This is direct recursion. Indirect recursion, when a function fun1 calls a function fun2, and fun2 calls fun1 again. So what happens here is fun1 indirectly calling fun1. This is indirect recursion. This is not very common, and we are going to mainly focus on direct recursion. Here are examples of very simple direct recursive programs. This is a simple C++ program, and this is a Java program. Now please pause this video and try to guess the output of these programs. These are direct recursive. Function fun1 is calling itself, and it's calling itself after printing a line. In both C++ and Java programs, we have a main function. we begin our execution from main function, and then main function calls fun1, and fun1 is a recursive function. It's calling itself, but there's something wrong in this function. The wrong thing is it keeps on calling itself. There is no termination condition. It's a never terminating function. So main calls fun1, fun1 prints gfg, and then again calls fun1, fun1 prints gfg, again calls fun1, and it keeps on happening. So how our C++ and Java are going to behave when you run this on a GCC compiler in C++, you get gfg, and then you get segmentation fault. And when you run this Java program, you get gfg, and then Stack Overflow. The reason is you have made so many function calls waiting to finish the execution, and internally compilers, they use stack frames to store the function data. That's why we are getting a Stack Overflow error. And after some function calls, these stack frame or that memory allocated for the function calls become full. And when that memory becomes full, you get errors in both C++ and Java. In C++ you get segmentation fault, in Java you get Stack Overflow. So how do we fix this problem? How do we correct these recursive functions so that they terminate at some point? Here is a modified recursive function that takes an integer as an argument and makes sure that it does not go in a never-ending situation if a user passes a positive value of an integer. Now please pause this video, take a closer look at this program and try to guess the output of it. The output of this program is gfg 2 times. If we pass any positive number, say 5, then it will print gfg 5 times. How does this program work? We have main function call. This is the first function where execution begins. The first line in main function is call to fun1. When you call fun1 with an argument value 2, what it does, it begins the execution from first line of fun1. And first line is to check whether n is 0 or not. So n is not 0. So we come here to the next line, which is printing gfg. So we print gfg. And after printing gfg, we have a recursive call, a call to itself with a parameter n-1. So it calls fun1 with parameter as 1. When this fun1 is called, it again begins the execution from the first line. This time again, n is not 0, so we do not go inside this if condition. We come here and we print gfg, right? We come here and print gfg. And after printing gfg, we make one more recursive call where the parameter is 0. Now when you call for 0, the execution again begins from here, and this time n is 0, so it immediately returns. And now it does not go here because there is a return statement, so it does not go here, does not go here. And when this fun0 finishes, it gives the control back to the caller, and the caller was waiting for this to finish, and caller has nothing more to do, right? Fun1 was waiting for fun0 to finish, and once fun0 has finished, it has nothing more to do. So fun1 finishes, then fun2 gets the control. Fun2 was waiting for fun1 to finish here, and fun2 has nothing more to do, so fun2 will also finish. Main was waiting for fun1 to finish, and main also does not have anything more to do, so main also finishes. So we get gfg as output, and all the functions, they finish their execution. The change that we have made from the previous program, in the previous program it was never ending recursion. Here we have added a parameter n, right, and we are calling for n-1, and we have added a condition for n equal to 0, and such conditions are called base cases. Here we have only one base case. The idea is this: in recursion, a function calls itself and keeps on calling itself. So there should be some point at which this calling should stop. To stop these callings, we write some terminating conditions, recursion termination conditions, and those are called base cases. In this example, you call fun1 for a positive number, say 5, it calls for 4, calls for 3, calls for 2, calls for 1, and then you stop at 0. You could stop at 1 also, or maybe some other number, and then your output will be coming accordingly. But there should be one stopping condition. It should not happen that it keeps on calling, and such stopping conditions are called base cases. Here is a typical structure of a recursive function. I'm assuming here that you are not using global variables or some other tricks to stop the recursion. a typical recursive functions that we generally write. So what we do here in this recursive functions is we have some return type, we have some parameters, then we have some base cases. In the earlier example, we had only one case. We are going to discuss many more examples of recursion where we are going to write multiple base cases. After base cases, we write some code and then we make a recursive call to the same function, right? We make a call to fun itself. And here I've written with at least one change in parameters. What it means is, if you are calling a function fun, say with a parameter n, and if you call it with n again, then it's not going to terminate, right? If you've written base cases in terms of n, unless you are not using some global variables to terminate, that we generally don't do. So if we are passing parameters, then we must change these parameters, and when these parameters are being changed, they keep on changing, and there comes a point where they reach the base cases. For example, in the previous code we had, say, initial parameter 5, then it reduces to 4, then it reduces to 3, then it reduces to 2, then 1, and finally say we have a base case to handle 0, then it stops at 0. You could write a base case to stop at 1 also, or 2 also, right? If you stop at 1, then it will print those many times, right? It will work accordingly. So if you stop 2, it will print 1 less time, right? So that's the idea of base cases. That's the general structure or typical structure of recursive functions. In the upcoming videos, we are going to talk about many more examples of recursion.